Good morning, students. Today we will discuss mole concept. Our today's agenda is as follows. At first, we will discuss gram atomic mass. Then we will discuss gram molar mass or gram molecular mass, whatever you say it. Then we will discuss number of moles and then Avogadro's number. So let's start with the today's topic. At first, I am going to discuss gram atomic mass. So what is the meaning of gram atomic mass? Gram atomic mass. What does it mean? Whenever we express the atomic mass of any element in gram, it is known as gram atomic mass. So gram atomic mass means whenever we express the atomic mass of any element in gram, it is known as gram atomic mass. The atomic mass of an element in gram, expressed in gram, expressed in gram, it is known as gram atomic mass. For example, carbon. The atomic mass of carbon is the atomic mass of carbon is equal to 12 mu. If we express it in as 12 g, that means the atomic mass of gram atomic mass of carbon is 12 gram. Another example, if we consider helium, atomic mass of helium is 4 mu. We can also call it as 4 gram. Okay, so this is the meaning of gram atomic mass. Next, let's come to the topic gram molecular mass or gram molar mass. Gram molecular mass. Like we have discussed gram atomic mass, it was the mass of an element. Gram molecular mass will be the mass of a molecule. The mass of any molecule expressed in gram is known as gram molecular mass. For example, let's consider CO2. Its molecular mass will be molecular mass of carbon, which is 12, plus oxygen, which is 16, but here is 2 atoms of oxygen, so we'll multiply it with 2. Finally, we get 12 plus 44 or 32, which is equal to 44 mu. 44 mu is the molecular mass of CO2. We can also express it as 44 gram. So this becomes the gram molecular mass of CO2. Another example is H2O. Its molecular mass 2 hydrogen atoms, so 2 into 1 plus 1 oxygen atom, 16, is equal to 18 mu. That means we can also express it as 18 gram. That means gram molecular mass of H2O is 18. Next, our main topic is number of moles. Number of moles. We'll represent it with small n. What is number of moles? Number of moles, simply mathematically we can define it. Number of moles equal to mass by molar mass. Molar mass means whatever molecular mass of the substance or the element is, we will represent it molar mass. अच्छा, ये molar mass we can represent one just simple example. Okay, after this discussion we will come to that. So mass by molar mass, number of moles equal to mass by molar mass. So what was need of this number of moles? Why did we need number of moles? As you know, number of moles is one of the 7 fundamental physical quantities. In chemistry, we deal with solid, liquid, gas, all the three phases at the same time. So there was a need of such a unit in terms of which all the physical quantities, all the whatever the phase you are dealing with can be measured. In chemistry, we deal with solid, liquid, gas, everything. So we need such a quantity, such a unit in terms of which we can measure solid as well as liquid as well as gas. So such a unit was named as moles. So number of moles is this, that's why number of moles was needed. So number of moles is mass by molar mass. For example, just a simple example. For example, if we have to calculate number of moles in 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 12 gram of carbon, so number of moles will be mass, which is 12 gram, divided by molar mass or atomic mass, whatever you are calculating. 12 gram divided by atomic mass of carbon is 12 gram. Now we'll represent atomic mass or molar mass in terms of gram per mole. 12 gram per mole, which is equal to 1 mole. Another example, B number. If we have to calculate, let's say number of moles in 64 gram of oxygen molecule. Now it's molecule. At first we dealt with that carbon atom. Now we are dealing with molecule. So here number of moles equal to mass by molecular mass. Now mass of oxygen is 64 gram divided by molecular mass of oxygen will be 16 into 2, which is equal to 32 gram per mole. 32 gram per mole. On calculating, we get 2 mole. That's how we can calculate the number of moles. Achha. One thing that you should remember, 1 mole of any substance, 1 mole of any substance means atom or molecule or ion contains 6.022 into 10 to the power 23 atoms. Any element, I should write here 1 mole of any element contain 6.022 into 10 to the power 23 atoms or molecule or ion of that substance. This particular number here, this particular number is known as Avogadro number. This particular number is known as Avogadro's number. which is denoted by capital N subscript A. Na approximately equal to 6 into 10 to the power 23. Just to remember this number will be frequently used in further numericals. So Na equal to 6 into 10 to the power 23. Now let's understand our whatever the theories we have dealt. Let's understand that with some numericals. First numerical, the most easy one, calculate the number of moles in 160 gram of NaOH. So here mass is given, which is equal to 160 gram. Molar mass, how many molar mass? What is the molar mass of NaOH? Molar mass is equal to sodium, its atomic mass is 23, plus oxygen, its atomic mass is 16, plus hydrogen, its atomic mass is 1. On calculating, we'll get 23 plus 17, which is equal to 40 gram per mole. Now number of moles equal to mass by molar mass. Mass is equal to 160 divided by molar mass 40. It's in gram per mole. On calculating, we get 4 mole of NaOH. Next example, we have to calculate mass of 2.5 moles of CaOH ka whole twice. Let's proceed for it. Here number of moles equal to 2.5. Its molar mass of CaOH. Molar mass of CaOH ka whole twice equal to, how much is this? Ca, atomic mass of calcium. Calcium is 40 plus atomic mass of oxygen, which is 16, plus 1. Since here two atoms of two molecules of OH, so we will multiply it with 2. Finally, we get 40 plus 34, which is equal to 74 gram per mole. Now number of moles equal to mass by molar mass, which is equal to mass. We have to calculate mass. Number of moles we are given 2.5 equal to mass divided by molar mass is 74. On calculating, we get mass equal to 74 into 2.5. We can rewrite it as mass, whatever mass we'll calculate, it will be in gram. So mass is equal to 74 multiplied by 100 divided by 4 into 10. On calculating, we'll get approximately let's calculate it, exact calculation we can do here. So 2 and this is 3 and 7 2 5. So here we have got 37 into 5, which is 185. So mass of 2.5 moles of CaOH ka whole twice, 185 gram. Let's come to another question. Now the question is asking, calculate the total number of molecules in 14 gram of N2 and something. Let's calculate for one. Question number A. At first look at the question. What is asking? Total number of molecules. Initially we were calculating only number of moles. Now we are going to calculate number of molecules. So how we will proceed? At first, let me write the steps. At first, calculate the number of moles. At first we will calculate number of moles. From there we will calculate number of molecules. So number of moles of N2 is equal to mass by molar mass. Mass of N2 is given 14 gram divided by molar mass of N2 gas. N2 is a molecule, so we will get its molar mass as 14 into 2, which is equal to 28. 28 mole is equal to 1 by 2 mole. Since we know that 1 mole of any substance, 1 mole of any substance is equal to Na molecule of that substance. So here 1 mole of N2 gas is equal to Na, which is equal to Avogadro. Now let's write it Na molecules of N2. So we have to calculate it for half mole. So half mole of N2 gas will be Na into 1 by 2 molecules of N2. Writing Na as 6 into 10 to the power 23 into 1 by 2, which is equal to 3 into 23 molecules of N2. 3 into 10 to the power 23 molecules of N2. If we had to calculate number of atoms in 14 gram of N2 gas, so number of atoms would have been, number of atoms is equal to, since one molecule of N2 gas contains 2 atoms of nitrogen, so 3 into 10 to the power 23, 3 into 10 to the power 23 molecules of N2 will contain 3 into 10 to the power 23 multiplied by 2, which is equal to 6 into 10 to the power 23 atoms of nitrogen. Atoms of nitrogen. This was the number of molecules of nitrogen. Now one molecule of nitrogen gas contains 2 atoms of nitrogen. So total number of atoms would have been number of molecules multiplied by 2. Now we have to calculate number of atoms in 18 gram of H2O. B number. B. We have to calculate number of atoms. At first let me write the steps. At first we will calculate number of moles. From there we will go to number of molecules. From there we will go to number of atoms. In 3 steps this question will be proceed. Atoms. At first number of moles. Step 1, number of moles. Number of moles equal to mass by molar mass. Mass of water is 18, molar mass of water is 18, which comes out to be 1 mole. Now since we have calculated number of moles, we will calculate number of molecules. As we know that 1 mole of any substance contain Avogadro number of molecule or atom, whatever it is required. Since here we are dealing with molecules, so 1 molecule of H2O, 1 mole of H2O is equal to 6 into 10 to the power 23 molecules of H2O. Molecules of H2O. This we know from Avogadro's law that 1 mole of any substance will contain 6 into 10 to the power 23 atoms, molecules, whatever it is, of that substance. Now since we have calculated number of molecules, let's go to the number of atoms. Now 1 molecule of H2O, 1 molecule of H2O is equal to 2 atoms of hydrogen plus 1 atom of oxygen, that is 3 atoms of 3 atoms of hydrogen plus oxygen, both combined I am writing. So 6 into 10 to the power 23 molecules of H2O is equal to 3 into 6 into 10 to the power 23 atoms. So it will come out to be 18 into 10 to the power 23 atoms. That's how you will calculate number of molecules, then number of atom, whatever is required in the numerical. Next question is calculate the number of chloride ion in 111 gram of CaCl2. Chloride ion. Okay. Again, a steps. Question number C. At first, calculate number of moles, then number of molecules, then number of ions. Now, molar mass of CaCl2. Molar mass of CaCl2. At first, we will have to calculate molar mass of CaCl2 is equal to calcium 40 plus chlorine 2 into 35 CaCl2, 35.5. Okay, so it will be 40 plus 71, which is equal to 111 gram per mole. Now number of moles. At first, step 1, I am taking step 1, number of moles. Number of moles equal to mass by molar mass. Mass by molar mass. Mass of CaCl2 is given in the question, which is 111 gram. So mass is 111 gram divided by molar mass 111 gram per mole, which is equal to 1 mole. From here, we will calculate number of molecules. Step 2, number of molecules. Since we know that 1 mole of any substance contains Avogadro number of molecules, so number of molecules here will be 1 mole multiplied by Avogadro number, which comes out to be Avogadro number, which is equal to 6 into 10 to the power 23. Actual value is 6.02 into 10 to the power 23, but here we can take it as 6 into 10 to the power 23 molecules. Now we have to calculate number of ions of chloride ions. Since one molecule of CaCl2 contains 2 chloride ions, so number of molecules is given. We can calculate total number of chloride ions. Step 3. Since one molecule of CaCl2 contains 2 chloride ions, so 6 into 10 to the power 23 molecules of CaCl2 is equal to 2 into 6 into 10 to the power 23 chloride ions, which is equal to 12 into 10 to the power 23 chloride ions. That's how we calculate number of atoms, number of molecules, number of ions, whatever it is required. Just this is very basic concept. Just you have to calculate number of moles. From there you can calculate number of molecules, number of atoms. Just multiply it with Avogadro number, which is equal to 6 into 10 to the power 23. Let's go to another question. Here the question is calculate the mass of one molecule of oxygen and one atom of oxygen. That's the whole numerical. No extra information is provided in this question. So let's proceed. How we can proceed? At first, one molecule of oxygen. As we know that 1 mole of oxygen is equal to 16 into 2 gram of oxygen, which is equal to 32 gram oxygen. Okay, 1 mole of oxygen is equal to 32 gram of oxygen. Now, as we know that 1 mole of oxygen is equal to Na molecule of oxygen. That is 1 mole. We can write it as Na 6 into 10 to the power 23 molecules of oxygen is equal to 1 mole oxygen, and 1 mole of oxygen contains 32 gram of oxygen, is equal to 32 gram of oxygen. Hence, 1 molecule of oxygen is equal to 32 divided by 6 into 10 to the power 23 gram of oxygen. Now, you can calculate it as 32, which is equal to 16 divided by 3 multiplied by 10 to the power minus 23 gram of oxygen. Molecule. We have just calculated molecule. Now, we have to calculate number of atoms, mass of one atom of oxygen. Mass of one atom of oxygen, B number. Since we know that one molecule of oxygen is equal to this much gram of oxygen. One molecule of oxygen is equal to 16 by 3 into 10 to the power minus 23 gram oxygen. Now, is equal to 10 to the power minus 23 gram. Now, one molecule of oxygen contains 2 atoms of oxygen. 2 atoms of oxygen is equal to 16 by 3 into 10 to the power minus 23 gram. इसलिए 1 atom of oxygen is equal to 16 by 3 into 2 into 10 to the power minus 23 gram, which comes out to be 8 by 3 into 10 to the power minus 23 gram. That's how we can calculate mass of one molecule, mass of one atom, whatever you have required. Just one basic concept that you should remember: how to calculate number of moles, how to calculate number of molecules, atoms. Just this is a multiplication with Avogadro's number, and nothing extra in it. Okay. Now let's come to another question, which is calculate the number of moles of sulfur atom, oxygen atom in 1 mole of this H2SO4, H2SO3 and SO2. From the formula of H2SO4, we can see 1 mole of, at first you should see it at molecular level. 1 molecule of H2SO4 contains 1 molecule of sulfur atom. 1 molecule of H2SO4 contains 1 molecule of sulfur atom. If we multiply both 1 with Avogadro's number. So it will become Na molecule of H2SO4 contains Na molecule of sulfur atom. Now, Na molecule means 1 mole. Na molecules means 1 mole. 1 mole of H2SO4 contains 1 mole sulfur atom. That's how we can do it. Again, for oxygen, you can look 1 molecule, 1 molecule of H2SO4 contains 4 molecule of oxygen, 4 molecules of oxygen. इसलिए Na molecule of H2SO4 contains how many? 4 not molecule, sorry, 4 atoms of oxygen. 4 atoms of oxygen. 4 atoms of oxygen. So if we multiply both with Na, so Na molecule of H2SO4 will contain 4 Na atoms of oxygen. Now Na molecule means 1 mole. 1 mole of H2SO4, here 4 mole of O2. It means we can write it directly from just looking at the formula. H2SO4, here hydrogen 2 moles, hydrogen 2 moles, sulfur 1 mole, oxygen 4 mole. That's how oxygen atom we can write it as like that. Now again in the second question, hydrogen 2 mole, just 1 mole of H2SO3, sulfur 1 mole, oxygen 3 mole. Now SO2, sulfur 1 mole, oxygen 1 mole. Oxygen, if we look at it, oxygen atom, if we talk in terms of oxygen atom, so O2 atom is 2 mole atoms of oxygen. Now let's go back to another question, which is equal to calculate the number of atoms present in 5.68 milligram of silicon. Number of atoms, we have to go for number of atoms. At first, from mass, we have mass. From mass, go to number of moles. From number of moles, multiply it with Avogadro's number and get the number of atoms. That's how you will proceed. At first, calculate the number of moles. From mass, calculate the number of moles. Number of moles equal to mass by molar mass. Mass is equal to 5.68 milligram. Convert it into gram. This is 5.68 into 10 to the power minus 3 gram divided by. Now, molar mass of silicon is 28 gram per mole. It comes out to be 5.68 divided by 28 into 10 to the power minus 3 mole. As we know that 1 mole of any substance is equal to Na atoms of silicon. 1 mole of any substance contains Avogadro number of atom, molecule, whatever it is required. Here we are dealing with silicon atoms, so we are saying that 1 mole of silicon is equal to Avogadro number of silicon atoms. Now let's calculate it for this. So 5.68 divided by 28 into 10 to the power minus 23 mole of silicon is equal to 5.68 divided by 28 multiplied by 10 to the power minus 23 multiplied by Na, which is equal to 6 into 10 to the power 23 atoms of silicon, which is equal to 5.68 into 6 divided by 28 into 10 to the power 21 atoms of silicon. On calculating we get 5.68 into 6 divided by 28, which is equal to 1.2 into 20, 1.2 into 10 to the power 21 atoms of silicon. That's how we calculate number of atoms. Now let's come to this question. Find the number of sodium and sulfate ion in Na2SO4, 14.2 gram of Na2SO4. We have to calculate number of ions. At first, write the steps. We have mass. From mass, go to number of moles. From number of moles, go to number of ions. Now calculate. Now let's do it. How we can proceed. Here the question is mass is given. At first calculate the molar mass. Molar mass of Na2SO4 is equal to sodium 23 into 2 plus sulfur 32, oxygen 16 multiplied by 4. On calculation we get 23 into 2, 46 plus 32 plus 64, which is equal to 46, 32 and 64, 142. So molar mass is 142 gram per mole. Now number of moles. Calculate number of moles. Number of moles equal to mass by molar mass. Mass by molar mass, which is equal to mass is 14.2 divided by 142 moles, which is equal to 1 by 10 mole. Now this is number of mole. Now we have to go to number of ions. Since this is number of 1 by 10 molecules of 1 by 10, no wait 1 by 10 mole. At first calculate number of molecules, then we will go to ion. Number of molecules, then ions. Number of molecules. From there we will go to number of ions. Now number of molecules. Molecules of Na2SO4. Since 1 mole of any substance contains Avogadro number of molecules, so 1 by 10 mole of this will contain 1 by 10 multiplied by 6 into 10 to the power 23 molecules of Na2SO4. Since 1 molecule of Na2SO4 is equal to 2 sodium ions. 1 molecule of Na2SO4 contains 2 sodium ions. Hence this much molecule. Hence 6 into 10 to the power 10 will 22 molecules of Na2SO4 contains 2 into 6 into 10 to the power 22 sodium ions, which is equal to 12 into 10 to the power 22 sodium ions. Now we have to calculate sulfate ions, number of sulfate ions. Since one molecule of Na2SO4 contains one sulfate ion, one sulfate ion. Hence 6 into 10 to the power 22 molecules of this will contain 6 into 10 to the power 22 ions of sulfate. That's how we calculate it. Now let's come to another question. One last question that I am writing. We have to calculate number of electrons. Let's calculate number of electrons in 1.6 gram of methane. Let's calculate. For example, this is the last question and very beautiful question this is. For example, total number of electrons in 16 gram of methane CH4. Total number of electrons in 16 grams of methane. How we will proceed? At first, let me write the steps. At first, calculate from mass. Mass is given. From mass, calculate the number of moles. From number of moles, calculate the number of atoms. Now we will calculate number of atoms. From number of atoms, calculate number of electrons. That's how we will proceed. Number of electrons. This is a step 1, a step 2, a step 3. In 3 steps, this question will be proceeded. Now let's come to a step 1. At first, we have to calculate number of moles. Number of moles equal to mass by molar mass. Mass is 16 gram. Molar mass is carbon 12 plus 4, 16 gram per mole, equal to 1 mole. A step 2, number of moles we have calculated. Now calculate number of atoms. Number of atoms, let's calculate. Here 1 mole of CH4 is equal to Avogadro number 6 into 10 to the power 23 molecules of 6 into 10 to the power 23 molecules of CH4. Okay. Since one molecule of, now think, one molecule of CH4 contains one atom of carbon and 4 atoms of hydrogen. 4 atoms of hydrogen. Okay, let's hydrogen atom, let's write it as that. Yeah, right. Now each atom of carbon, if we consider, each atom of carbon contains 6 proton and its nucleus and 6 electrons wandering about its nucleus. So one atom of carbon is equal to contains 6 electrons and 4 atom of hydrogen. Each atom of hydrogen will contain one electron. So 4 will contain how many? 4 electrons. Hence total number of electrons in one molecule of CH2 total number of total number of electrons in one molecule of CH4 is equal to 6 in carbon plus 4 in hydrogen, which comes out to be 10 electrons. Hence, one molecule of CH4 contains 10 electrons. Now we have 6 into 10 to the power 23 molecules. इसलिए 6 into 10 to the power 23 molecules of CH4 is equal to 6 into 10 to the power 23 multiplied by 10, which comes out to be 6 into 10 to the power, which comes out to be 6 into 10 to the power how much? 24 electrons. That's how we will calculate it. So that's all, that's everything about mole concept. So what you have learned today, let me summarize. At first you learned about atomic at first, yeah, gram atomic mass. At first you learned about gram atomic mass, which was simply atomic mass of any substance represented in terms of gram. Second, you learnt about gram molecular mass, or it is also known as gram molar mass, which was the mass of a molecule of any substance, gram molar mass. Then you learnt about number of moles, which was required to represent all the phases in chemistry in just one unit. Number of moles, which was mass by molar mass. Then you learnt about Avogadro's number. Avogadro's number. Avogadro's number was simply number of atoms, number of molecules, number of ions in 1 mole of any substance. Its value was 6.022 into 10 to the power 23. Approximately we can write it as 6 into 10 to the power 23. That's all you learned. And finally, in order to calculate anything from number of moles, you have from mass you will have to go to number of moles, then go to number of atoms or number of molecules. From there you can go to number of electrons. That's everything in